Hello again everybody, and welcome to another tutorial, and this will be about schematics, how to read, understand schematics, because it's a very confusing subject from what I see, and it takes a lot of practice and dedication. So we're going to go over the basics of it. If you understand this, you should know any make or model, and you can apply the theory to anything. But please subscribe to my channel, Automotive, Electronic Schematics by Joseph, to find very detailed troubleshooting diagnostics about wiring diagrams, how to understand automotive diagnostics. Now let's begin. First of all, before you start with a diagram, you have to understand the basic functions, components, symbols, and wiring. Wiring has different abbreviations for the color of the wire, as you see over here. So if you're not sure, you always refer to this chart over here. White is W, see light blue, LBL, light green, LG, if you're not sure. Because these are what's used constantly, all the time. If you want to do automotive, you have to refer to the color of the wire to find what you're looking for. That's number one. Now, number two, the symbols. And first, before the fuses goes to batteries, it always tells you the condition of how the current or the voltage is. So hot and run or start. This relates to your ignition switch, in which condition, in which position your ignition switch has to be for this current to flow from the battery. It has to be in run or start. The difference is sometimes it's hot at all times. That means we don't even need the engine to be on or even the ignition key to be turned. Sometimes you just need a switch. So pay attention to these things. Now, B+, we always need a B+. We always need a voltage. It could come from a power source. In this case, obviously in automotive, it could come from the alternator. It could come from a battery. So whenever you start from the top. Most schematics have the B+ at the top. But don't assume all the time. Sometimes they are not. Sometimes they are here, and you have to go trace it up here. So as soon as you see a fuse, you know it's coming from a B+. As is the case here, as is the case here. Now, when you look at this, you see, like we just said, this is a connection and the color of the wires. So when you come to these points, you see that this is a connection. So you go this way, current will flow. Remember, as I said multiple times, voltage does not flow. Current only flows. Voltage is a pressure, electromotive pressure that pushes the current to do a work to the load. The load could be a relay. The load could be injectors. The load could be a motor, a stepper motor, anything, a starter motor. We have to understand the basic concepts. Now, whenever you look at these things, it tells you the component names. Okay? These are the pins. This is ignition coil. The dotted black line, not dotted, the solid line means that this is contained in one unit. All these coils going to the spark plugs are contained in one unit, ignition coil. And I did many videos about ignition coil, how it creates spark. You can refer to my channel. Now, other things. Sometimes this is a splice or a connector. This means this is connected to this, it's connected to this. It could be a connector, or it could be a splice, where many wires go into one wire. Or it could be a connector, physically, where you can go and detach the connector. Now, if you look and try to understand, at first glance, it's a little confusing. But once you know all these components appear, any make or model. So if you understand this, you will understand any make or model and any system. They might have different names. Instead of a PCM, which is short for Powertrain Control Module. It'll be called the ECM, Electronic Control Module. The functions are the same. The inputs, we need inputs and we need outputs. How do you know what an input is? How do you know what an output is? We're going to explain that. First, starting whenever you see a B+, Automotive is big on relays. All over. There are relays all over. So therefore, once you see a B+, you expect to see a relay in the schematic. Current flows here. As I've stated in other videos, how it happens, this creates a magnetic field around this. The switch is now flipped. The dotted line means that this is controlled by this. When this current flows here, this switch will flip over here. So once this flips, we know that it closes the path for another circuit. So we look for another path of circuit. As you see over here, B+, once, and I dotted it in red, the B+ will follow in this. Now, once you see so many lines, that means usually it's B+. See all this? B+, B+. See this? B+, B+, B+. So therefore, look for these things. The other thing is, now, ignition control module over here, we have ignition coil. Modules, when you see a lot of numbers, that means they are signifying the terminal numbers, the pins. This is like an enclosed module. So therefore, if you're looking for a specific thing on the module or a terminal, you'll be following this pin number, 11, 12, 16, 3, whatever you need. Now, power control module has sometimes 200 pins. So therefore, you'll be referring to all these different numbers, as you can see. Now, to get to the nitty-gritty, to get to the hard stuff. Once we have, these are called fuel injectors. Around the PCM, you'll always find a couple of things. Standard. So once you look for a PCM, PCM is the brain, is the computer of the automotive. It's like the microprocessor. And you have RAMs, you have ROMs, memories, you have instructions, what to do when you start up the car. Now, before the engineers write all these possible situations that can occur and how the power control module should react to those situations. How much air is coming in? How much is the temperature coming into the air chambers? How do we control then the fuel? All these things are instructions that are made by engineers and are put into the chips, which is in this power control module. So therefore, I just stated a fact. I just said something. I just said, first of all, we have ignition coil. We have ignition control module. What's the input? What's the output? In order to control how much fuel goes into each cylinder, we have to know the air. Mass in grams per second. Mass airflow sensor tells us this. When we open throttle, which means we're accelerating on the gas pedal, we're opening up something called the throttle body. The throttle plate allows more air to go into the air chamber, into the intake manifold, which is obviously the engine. We have to decide something, or the PCM has to decide how much fuel to give, this dependent upon how much air is coming in. More air, more fuel. Less air, less fuel. As I stated in so many videos, the ratio of 14.7 parts air to 1 part fuel is what we're looking for. And the computer tries to adjust that ratio as best as possible to receive proper emissions. Proper emissions includes oxides of nitrogen, carbon monoxide, carbon dioxide, hydrocarbons, to get the correct pollutants. Anyway, so again, once you see a PCM, the computer, you expect to see inputs. You expect to see outputs. Again, what's inputs? Right here, sensors. We have plenty of them. So therefore, you have a mass airflow sensor that we just talked about. Mass airflow sensor is an input. Any sensor is an input to the computer. Remember, the computer wants to know the present conditions. And how does it determine that? By sensors giving it information. Think of it like you're going to a doctor and he asks you, well, what's wrong? What are your symptoms? You tell him all your symptoms. Well, these are the symptoms. The air is cold. The air is hot. A lot of air is going in. Little air is going in. Right? Now, that's one sensor. Expect to see 1, 2, 3, even more sometimes. 4 pins. At least 3 pins, mass airflow sensor. That's an input. Ignition control module will be controlled, as I made a video on it, will be controlled by the PCM. When to create spark, either later or before intake valve is opened, depending upon a lot of conditions. When to open, when to create spark. Sometimes you have pre-ignition. Sometimes you have detonation, which means you have hot spots in your in the engine. That means you have to retard. You have to delay the spark. All this is determined by the PCM when to open up the winding. Anyway, as you see over here, B plus has to come to the ignition coil, to the windings. And then the outputs will go to these, called the secondaries, and then spark is created. Again, now, PCM's oxygen sensors are inputs. You should see 4 pins, a heater that heats up around 700, 800 degrees or more. And then the PCM will pay attention to the inputs of how much oxygen is coming out of the exhaust manifold. Or the catalytic converter. There's about 4, 6 oxygen sensors today. Anyway, these are inputs. It's a sensor. Okay? Now, what's an output? A fuel injector. We control the fuel. Therefore, it is an output. That's how you break it down. Expect to see sensors are inputs. Remember, whatever controls the engine is the PCM. Whatever controls accessories, lights, doors, locks, theft systems, those are the body control module. Anything related to performance of engine, where we alternate or change the fuel ratio, is the PCM. So look for things like that. Okay? So these are grounds. What you always have to do with the PCM is look for a B+. It has to have a B+, a 12 volts going in. Okay, now the other thing is the abbreviations or the components or symbols for them. This is a chart of all, or basically components that are used very, very often. Knock sensor, which gives you pre-ignition, that you know the level. Solenoids, diodes, these are the popular ones. Fuses I just talked about, circuit breaker I talked about, fuse link, ground, splices, all these things are common in every schematic that you know in automotive. So take a look at them and get familiar with them, because you will run across them in every single schematic, regardless of make or model. Doesn't matter, European, Asian, American made, these are the symbols. So a heater, like we just talked about, an oxygen sensor, 2 filaments in a bulb sometimes. Bulbs, you have to have bulbs in lighting systems, right? Speed sensors on the tires, right? Resistors, sometimes you have variable resistors. So take a look at these. I hope this was informative. So please, again, subscribe to my channel, and you will find videos about scanners, about OBD2, and not just the measurements of what it tells you, but to understand the definitions. When you measure something on a scanner, what is closed loop? what is open loop, what is the oxygen sensor supposed to be, the correct level. All these definitions are in the videos that I made for scanner OBD2, and you will not find it anywhere else on YouTube. I guarantee that. The complete definitions of every measurement on a scan tool, regardless of what scan tool it is, Snap-on, doesn't matter what it is. The principle is always the same. So once you understand this principle, you should understand the systems, and you just break down the system. Thanks for watching. Hope to see you in the next video.